Greetings to all. Welcome to PCM Under One Roof, our YouTube channel. In this video, I will explain what vectors are. There are many familiar physical quantities associated with a single number and unit. As an example, a gas cylinder can hold 65 liters of gas. In this case, 65 is a number and liter is a unit of measurement. It is possible to observe more of these types of physical quantities. Let us look at a few more. The duration of a seminar is 60 minutes. The energy content of a chocolate bar is 260 calories. We observe a single number in all cases and it is associated with a unit. They are known as scalars. Therefore, a scalar is a single number with a unit. Simple algebraic rules can be used to add or subtract scalars. In addition and subtraction, the scalar should carry the same unit. Let us consider this example. The seminar lasts for 60 minutes and the interval time is 10 minutes. As a result, the total time is 60 minutes plus 10 minutes, which is 70 minutes. Please understand that there is a difference between a scalar and a real number. The scalar is a single number with a unit. As an example, 50 hours is a number associated with the unit of time. Taking just 50 as an example, it is a real number. It does not contain any units. Let us consider another scenario. The people are stranded at a distance of 500 kilometers from the airport. They must be rescued. The term 500 kilometer refers to any direction from the airport. The direction may be east, northeast, northwest or southeast. We do not know in which direction we should send the flight. If I inform the pilot that people are stranded at 500 kilometer southwest of the airport, then it is relatively easy to guide the flight to the desired destination. There are some physical quantities that are associated with magnitude and direction. In this example, 500 kilometers represents the magnitude and southwest is the direction from the airport. A vector is a quantity that is associated with magnitude and direction. The direction of a vector is very important in vector physics. As an example, a flight to the north and a flight to the northeast have different destinations. In this case, the distance is the same but the direction is different. On the previous slide, we saw that the magnitude of both flights was the same but the direction was different. Let us begin by looking at the simplest vector quantity known as displacement. Only mentioning distance like 500 km or 600 km is a scalar. If you put the same distance along with a direction like 500 km north or 500 km northeast, you get a vector called displacement. The vector is normally represented by a line with an arrowhead at its tip. It is always pointing in the direction of a vector. For example, in a displacement vector, it is pointing in the displacement direction. A vector's tail is its starting point and its tip is its ending point. Here, A is the starting position and B is the ending position. A vector quantity is represented by a single letter and an arrow above it. The length of the arrow indicates its magnitude. Vector magnitudes are represented by the same letter as the vector without an arrow at the top. A vector's magnitude is always positive since we are taking the modulus. Let us take a displacement vector in the positive x-axis or towards the east. The vector is represented as 500 kilometers towards the east. The length of the vector or magnitude is 500 kilometers. Now, let us look at the second displacement vector. In this case, the vector is pointing west or in the negative x-axis. the vector can be represented as 500 km towards the west. The magnitude is 500 kilometers. It should be noted that both cases have the same magnitude. An important thing about vectors is that they don't depend on actual paths taken. A straight line segment directing from the starting point to the ending point is all that is necessary. Let us take a flight from point A to B towards east. Here, A is the initial point and B is the final point. Let us take a look at two scenarios. In the first scenario, the flight goes from A to B directly and covers 500 km. In this case, the distance is 500 km and the displacement is 500 km towards east. Now, let us talk about the second scenario. In this case, the flight follows a curved path and covers a distance of 1200 km. The distance in this case is 1200 km, but displacement is still 500 km towards east. This is due to the fact that the vector does not depend on the actual path taken. Let us examine a few more scenarios. During a flight, a distance of 500 km is covered from point A to point B towards the east and 200 km from point B to point O towards the west. In this overall movement, the starting point is A and the ending point is O. The distance travelled is 700 km and the displacement is 300 km towards east. Keep in mind the displacement vector is not affected by the actual path. Let us go to next case. During a flight, a distance of 500 km is covered from point A to point B towards the east and 700 km from point B to point O towards the west. In this overall movement, the starting point is A and the ending point is O. The distance travelled is 1200 km and the displacement is 200 km towards west. Let us take a look at the last case. The flight moves 400 km from point A to point O towards east and 400 km from point O to point B towards north. Here, A is the starting point and B is the ending point. Total distance travelled is 800 km. The displacement, on the other hand, is a straight line segment from point A to point B. It is 565.7 km in northeast direction. Now, let me explain the difference between a real number, a scalar, and a vector. So, let us take 50. It is a real number without units. 50 kilometers is a scalar due to the fact that the number 50 is associated with a unit. In the case of 50 km towards the east, it would be a vector because it is associated with magnitude and direction. A problem is presented here to test your understanding. A plane flies 400 km from A to O, 300 km from O to B and 500 km back to A. Determine the total distance travelled and displacement. Please share your answer in the comment section. Thank you. Please share your comments about this video.